Hey guys, welcome to 4.1 video 2 edited version. So first, in order to find the intervals of increase and decrease, I need to find my derivative. So I did the quotient rule. Low d high minus high d low, square the bottom. So then to simplify my numerator, I distributed this 4x to the third to get 4x to the fifth minus 32x to the third, and I multiplied these two here. Combining like terms, my numerator becomes 2x to the fifth minus 32x to the third over my denominator. So in order to find my critical values, I need to find not only where my numerator is equal to 0, but also where my denominator is equal to 0, because this function is not continuous on my denominator. So for continuous functions, it's easier when we have a function, our denominator, we have to also set that equal to 0 for our critical values. So here are my critical values of interest for my derivative, where they either change from 0, they're either equal to 0 or they're undefined at that value. So I've set up a sign checking chart here with all of these critical values. The critical values from my numerator where it's equal to 0, and my critical values from my denominator where it's not defined. So now I can do a sign check in each of these intervals to check where it's increasing or decreasing. So remember that I'm plugging in any value less than -4 here. I chose -5. My denominator will always be positive here, so I don't even have to think about my denominator when I'm checking for positives or negatives. I'm just going to plug into my numerator. So this would be a negative multiplied by a negative multiplied by a negative, which is a negative. Therefore, it's increasing on that interval. And here it's equal to 0, here it's equal to 0, here it's equal to 0, here it's undefined. Undefined, so we don't confuse ourselves. So now, checking between -4 and -8, I can plug in -3. That will be a negative multiplied by a negative, a negative multiplied by a positive multiplied by a negative. So that would make a positive here, so that means it's increasing on that interval. So now between -8 and 0, I could plug in x equals -1. Let's check what that is. That's a negative multiplied by a positive multiplied by a negative, which is a positive, so it's increasing here. So now checking between 0 and √8, I can plug in 1. That's a positive multiplied by a positive multiplied by a negative. So that's negative here. So I'm checking my derivative here, and this is my function. So now checking x equals 3, I get a positive, positive, negative, negative here. And then for x equals 5, I get a positive, positive, positive. So sorry, this is a negative and this is a positive, so this is increasing. So now, if I am stating my intervals of increase, okay, I see it's increasing from 4, including it exists at 4, or -4, until -√8. So -4 until -√8, but notice it does not exist here, so I can't include that value. Union with, it's still increasing from -√8 until 0, but now I can include that value because it exists there. And then also one more union with 4, it does exist at 4 until infinity. So now if I want to look at decreasing, let's look where it's decreasing. From -infinity until -4, it does exist at -4. So we'll close it there. And then it's also decreasing from 0. It does exist at 0, so I'll include that value until √8. But it has infinite, it does not exist there. And then union with positive √8 until 4. So for these non-continuous functions, we must also check where it does not exist, and where it does not exist, our intervals of increase and decrease are open on those endpoint values.